Okay, so I told you I would do problems 1, 2, 3, and then I think I said 15, and then I think I said 22. So we're going to start with 1. Oops. Having a little trouble here. Just love technology when it works. Alright, so now let's see if we can get anything done. So the very first question says that you have a child playing in the floor of an RV. The RV is going down the road at a constant velocity. He has a toy cannon, and then he shoots the toy cannon. And the RV is going that way, and he shoots the cannonball that way. That's the first part. And then he does the same thing, but this time the RV is going like that, and he shoots it back that way. So we want to know, how does it look, the amount of range, how does the amount of range look from the child's point of view, and then from someone that's standing outside watching this action. So from the child's point of view, it doesn't matter which way he points it. There is no difference. The range is the range. Because range is simply going to be dx, and it's going to be equal to vxt, and none of that is changed for this or this. Now, from the person outside the RV, what I want to say is if he points the cannon toward the front of the RV and shoots it, and I'm standing outside stationary on the ground, I would say that his range is much shorter because because to the person standing outside the RV catches up to the projectile. And then if he shoots the cannon towards the back of the RV, the range is greater, because basically what I see standing stationary outside the RV, I see the RV appear to drive out from under the projectile. So the range is greater since a stationary observer would see the RV drive out from under the projectile. Okay, the second one that I told you I'd do, number 2. Number 2 says 2 projectiles are launched from ground level at the same angle above the horizontal and both return to the ground level. Projectile A has a launch speed that is twice that of projectile B. There's no air resistance. Sketch the trajectories of both projectiles. If your drawings are to be accurate, what should be the ratio of the maximum heights in your drawings, and what should be the ratio of the ranges? Justify your answers. So I said, okay, well, here's one, and I'm going to shoot it off. This one's going to be projectile A, and I'm going to shoot it off at 2V, and projectile B is going to be shot off at just plain old V. The angles are the same, and so what I said was, since projectile A is fired with twice the velocity of projectile V, the projectile will have twice the range. And remember, range is just dx of projectile B. Okay, now we have to look at the time. And when you look at the time, there was no acceleration for the horizontal. For the vertical, though, d is proportional to t squared, and that comes from the equation. Okay, so since d is proportional to t squared, this is the same for both of them. That's the same for both of them. Nope, that's not true. Sorry. This is twice as much. But they both experience the same acceleration, so d is proportional to t squared. And what I know is that d up for projectile A is 4 times greater than B up for projectile B. And you can put numbers in and do all that math, but that's how it's going to turn out. Okay, the third one. The third one says the altitude of an Air Force glider is increasing at a rate of 6.8, so this is my 6.8. And I had it initially moving horizontally along the ground at a speed of 15.5. So they want to know, what is that right there? Well, let's just Pythagorean there. 6.80 squared plus 15.5 squared. And when I did that, I got B to be 16.9 meters per second. And I believe it just wants the magnitude. Yeah, so since it wants the magnitude, I don't have to mess with the angle. All right, then I told you I would do number 15. So number 15 is one about the diver. And so if I can find my work on 15, here's what I said on 15. I know that this is V. I know that my angle is theta. And I know that my V was 8.9. So anytime I see an angle, I use sine of theta, which is 75 degrees. Let me see if that's right. Yep. Times my hypotenuse of 8.90. And that gives me the initial speed in the y direction. And I got that to be 8.60. And then I did the cosine of 75 times 8.9. And that gave me Vx, and Vx was 2.30. All right. Well, they want to know, determine her initial velocity, both magnitude and direction. And that's what happens when she gets to the ground. So I messed that up big time. So let me fix that. The math is good, but it's actually this side right here. And it tells you that she makes a 75 degree with respect to the horizontal, so that's my 75 right there. So this was actually my VF, because that was her coming down, and that was my VX, which doesn't ever change. So sine of 75, here's my hypotenuse. And what they want to know is, what was her initial velocity, both magnitude and direction. So if she, it tells you that she springs upward, so there's got to be something going on like that. And this is going to stay the 2.30 because Bx never changes. So they want me to give them that and that from the initial uprising. Well, the board was 3 meters above the water. So what I said was, if that's true, then, let me get a different color here. She's doing something like that. And if I could find that speed right there, her vertical speed right there, then I could do all kinds of miraculous things with that, because I know she's going to continue on down, and by the time she gets to the water, this would be the 8.60 that we were talking about, and this would be the 2.30. So what I said was, well, Vf squared equals Vi squared plus 2AD. When she gets to the water, she's vertically going 8.60. Don't know what this Vi would be. Gravity is 9.8. And I'm talking about her just going from her original height of 3 meters down. So when I did that math, I found out that at that point right there, her Vi was 3.89. And that just brought her to that level that she launched from. I haven't dealt with this at all. Who knows what's going to go on there. Okay, so then I said, well, if that's true, then at that point right there, since it's symmetrical to this point over there, this would be the 3.89 coming down. That would also be 3.89 as she left, because she's beginning at 3 meters above the water, and this is 3 meters above the water here, so that has to be the 3.89. So I said, well, the tangent of theta has to equal 3.89 over 2.30. And I found theta, and theta was 59.4 degrees above the ground, or with the horizontal, I guess I could say. But I'm not done, because they want to know, what is this right here? Well, that V is going to be the square root of 2.3 meters per second squared plus 3.89. Don't forget to square it. So when I solved for that V, I found out that her launch velocity was 4.52 meters per second. All right. So let me see where we are time-wise. There we go. All right, so I'm going to stop there.